Now that we have calculated land productivity individually, let's move on to land cover change. So I'm going to click here under execute remotely, and the dialog window is going to pop up. So here we can see the initial year, the final year, added definition, the region of interest, so we can confirm. Let's not forget to name this task. So I'm going to call it Belize land cover change. And here I'm doing the exercise showing the baseline period. So I'm going to do it from 2000 to 2015. So, and I'm going to change the initial year here for 2000. So the European Space Agency Climate Change Initiative layer representing land cover classes for the entire globe spans from 1992 to 2022 currently. So here for the baseline period, I'm going to be doing analysis of land cover change from 2000 to 2015. Here is the transition matrix. So we're going to show how to interact with it in just a second. But first, I'm going to show you how to match the original land cover classes coming from the ESA CCI global land cover data to the 7 classes that UNCCD recommends as default land cover classes. So here under input code and under input class, we have the ID, the original ID, and the thematic class, the label from the ESA CCI global default land cover dataset. And then what we do is just matching interactively. So Trends.Earth allows you flexibility to match. So cropland, rain-fed, we're going to match it to cropland and so forth. So all the original land cover classes coming from the ESA CCI are matched to one of the UNCCD recommended default classes. Once you interact with this dialog, you can save this definition to a file. So later on, you don't have to redo this exercise over again. You can simply load the definition from file. And once you have changed this, but you are not satisfied, you can always reset to default. So this is how to match the original land cover classes to the UNCCD 7 classes. And here is the transition matrix. So what we have here is the original land cover classes at year 1, at the initial year, and the land cover classes at the target year. So this is showing a pixel that initially was grassland and now it's tree covered. So it's showing a positive increment here, improvement. Otherwise, like if tree covered initial year and then moved, changed to grassland, this is going to show a degradation change. So users are flexible to interact with the tool, just like selecting the cell and changing the sign. But if they're not satisfied, they can always reset the table. Similarly, they can save this table to a file and then load this the saved table interpretation later on. So once I interacted with this parameterization, I'm going to execute this task.